Hello everyone, I'm Julien Tiron. I'm a software R&D manager at Silicon Labs, and I'll continue on Miranda's track around Z-Wave with a short update of what the Z-Wave Alliance has been doing in the past years and where we are seeing the evolution and extension of the Z-Wave protocol. So first of all, a bit of history from Silicon Labs' point of view. So Silicon Labs acquired the Z-Wave technology in 2018, and from the start, opened it up, creating an SDO, so a standard development organization, to open up the door to Z-Wave. So before 2018, Z-Wave was a closed source protocol that was developed by a company that was selling the hardware. And with that move, Silicon Labs tried to open the door to a larger ecosystem around the Z-Wave technology. So since 2018, the Z-Wave Alliance is in charge of the protocol development, and there have been a lot of evolution of the protocol. So we had a highlight about what is happening on the open source side and with Z-Wave long range. I'll go a bit more in detail into the rest of the specification evolutions. So not talking too much about long range, because tomorrow there'll be another keynote dedicated to the Z-Wave long range specification, but showing you where Silicon Labs sees the growth happening and the evolution of the Z-Wave protocol. So first, as a reminder, I would like to go through some of the strengths of Z-Wave long range. So Z-Wave has been an established home automation protocol for many years, and one of its strengths compared to other alternatives, and still is to this day, is its sub-GHz component compared to Zigbee, to Thread 15.4. The use of that sub-GHz band is enabling longer range communication and more reliability also in the communication. So added to that, the protocol itself has been reliable and has been evolving to increase security. So over the years, so Z-Wave started 15 years ago, and since then the specification has been evolving with the addition of S0, S2 security level, improving its reliability and security. And from, let's say, the major evolution point of view, Z-Wave long range has been introduced a few years ago by providing a simpler network topology for Z-Wave. So Z-Wave Classic is based on a mesh topology where a device in your network will route messages to other devices. With Z-Wave long range and its longer range, that was not needed anymore. So the decision was taken to simplify the network piece and to have a star topology. So between your end device and your gateway, there is a direct communication leveraging that longer range. And finally, the interoperability piece, as Miranda mentioned, in the home automation market, it's key. And within the Z-Wave ecosystem, there is a certification process to ensure that the gateway, the Z-Wave gateway you will buy, will work with every Z-Wave end device you will acquire. And that's even truer now with the Z-Wave ecosystem being open and with multiple vendors, that certification program ensures that your device will communicate with each other. So just shortly, Z-Wave long range compared to Z-Wave Classic, we retain the 100 kbps PHY. So it's a modulation that is still able to provide really high data rates. So you can easily do a network, a firmware update over the air without any issue using that PHY. But it will be a longer range communication between the gateway and your end device. And you can see that compared to the Z-Wave classic network, you will be in direct communication with the Z-Wave gateway instead of relying on other devices. And from the capability point of view, the addressing of Z-Wave long range allows to reach several thousands of devices connected to the same gateway. So it's also a way to reach other applications than just home automation. With that capability, that longer range, you can imagine that Z-Wave long range can serve other applications than just the standard home automation standards. And it's pretty easy to deploy. Every single Z-Wave classic chip is able to support long range. At least the latest Silicon Labs Z-Wave chip, they have the dual capability to support classic and long range, and they are interoperable. So whatever your customer is using in its deployment, so for example, if he has a home assistant gateway and he wants to use Z-Wave classic, he can with every single Z-Wave customer he will buy on the market. Same if he wants to do Z-Wave long range, the latest devices that are tagged with the Z-Wave long range logo, they'll be able to connect to their gateway using Z-Wave long range in that star topology I presented. And why should you go or adopt in 2025 Z-Wave? There is multiple factors, but I talked about the SDO, so the Standard Development Organization, that has allowed Z-Wave to move from a single semiconductor vendor to multiple providers, and that allows to have a second source in your product if you need it, and to have competition as well. So not only Silicon Labs, but if you have issues, you can always rely to our competition with the Tiron IoT coming as well with their own hardware platform. And contrary to other protocols, you are not relying on Silicon Labs IP within Tiron IoT IC. It's really their own design that is differentiated from the Silicon Labs one. If we compare to LoRa, where they have their IP that they sell to other vendors, here we are talking about completely two different hardware solutions. Obviously, the Z-Wave Alliance has opened its door to members, and they can impact the specification evolution. So that's what happened last year regarding something I'll present later around energy harvesting. And you can access multiple working groups regarding security, certification, and impact the direction of the Z-Wave Alliance that way. And finally, I won't extend too much, but obviously you've seen the previous presentation. There is some different ecosystem around Z-Wave that are pushing the adoption both in the home automation, but also outside and trying to push Z-Wave long range to other use cases. So the first major point I wanted to make in that keynote, it's on the specification evolution. So we just discussed long range, but beyond that, and more recently, we have specification evolution regarding security. So for example, we recently introduced S2v2, and that's a new security level for Z-Wave that improves the security encryption in the network. And that's obviously an improvement compared to S2, where we will encrypt more of the data going in through the networks. And that's helping with the Cyber Resilience Act that will be is adopted in Europe. Z-Wave will be ready as a protocol to let your product pass that CRA check. I was talking about energy harvesting. So last year we had a new member that brought that push for a specification update to allow energy harvesting device in Z-Wave networks. So the working groups of the Z-Wave Alliance have worked together to come up with a new device type, what we call wake-on-event device. That is a profile dedicated for really low power device connecting to a Z-Wave network. And that's relying mostly on Z-Wave long range and really tailored for energy harvesting devices. So that's something you will see, or that you can push inside the Z-Wave Alliance if you have your own view of what could be developed in the Alliance. That's something that you can easily push through the Alliance. And finally, one example I'll take about Z-Wave is known for its strong application layer through common classes. And one of the focus last year of the Z-Wave Alliance was to develop the door lock application with two new common class, so user credential and active scheduling, that improve the depth of your door lock by providing new layers to handle accesses, PIN codes, and credentials. So that's for the specification updates from the Z-Wave Alliance. Now I'll go a bit more on the Silicon Labs side with what we are providing to enable developer with Z-Wave. And the new trend in the IoT is to provide platforms that are able to do multiple protocols. And that's what we are doing with the EFR32ZG28. So that's a 32-bit SoC that is included in the home assistant antenna, and that support both sub-GHz radio that can do Z-Wave, standard FSK, YSUN, but also support a 2.4 GHz radio that can be used for Bluetooth. So you can see that it's a platform with a pretty big memory, with a Cortex M33, with an embedded secure element as well. So I was talking about the European Cyber Resilience Act. That's also something that is key in every new design to allow you to validate new firmware that you would upload to your device, or to support the security algorithm involved in the Z-Wave protocol. So with that hardware architecture, it opens up new development use cases with devices that can leverage both Z-Wave and Bluetooth. One way to leverage it is to use what we call switch multi-protocol. It's an implementation that relies on basically having several applications in Flash and using a dedicated bootloader, boot manager, to switch between your applications. So one standard use case is doing a firmware update over BLE. So our EFR32 would act as a BLE device that you can update through your phone and update the Z-Wave application. Whereas previously, when you wanted to update the Z-Wave devices, you had to rely on the Z-Wave gateway to upload your firmware to the end device. So that's not the case anymore. And now you have the option to rely on a standard smartphone to update your Z-Wave device. Another use case that can be used with this software architecture is to decide which protocol you will use during the provisioning. For example, Amazon Sidewalk is a new sub-GHz protocol from Amazon, and it's also supported by our ZG28 hardware platform. At provisioning time, depending on the home network configuration, whether it supports home Amazon Sidewalk or Z-Wave, your device will be able to choose which network to use by booting the right application. The second option we provide is a bit more technically involved, and there it's a trade-off on performance of your network. what we'll do is do dynamic multi-protocol. So in the same application, you will leverage the two protocols. So part of the time of the radio will be spent on standard Z-Wave communication. The rest of the time, you will open up small windows to do BLE communications. So Bluetooth is a pretty soft protocol in terms of timing. You can skip connection windows. And with that capability, we are able to maintain two profiles, one on the sub-GHz Z-Wave radio and the other on the Bluetooth 2.4 band. So for those multi-protocol implementation, our customers are more looking at live diagnostic of what is happening on the Z-Wave radio, or also device commissioning to connect the Z-Wave device through Bluetooth. So to summarize my keynote, so the Z-Wave specification is evolving on the security side with Z-Wave long range, with new command class implementation. We see a lot of activity in the different working groups of the Alliance. As you've seen with the previous presentation, there are ecosystems that are pushing and investing into Z-Wave. And finally, the multi-protocol aspect, now that if you have an idea for an IoT device, you can rely on Z-Wave, but not only, with hardware platform that will support both 2.4 and sub-GHz radios. If you are interested to know more about Z-Wave, so tomorrow we have a dedicated session keynote from our Z-Wave Alliance chairman, Avi Rosenthal, that will be specific to Z-Wave long range. Just after my session, we have a panel discussing Z-Wave. And finally, if you want to check out the Z-Wave long range demo we have, Silicon Labs has a booth B7. And worked with, by end of November, we have a worked with event, which is virtual and where you can attend a lot of our session about our multi-protocol offering. Thank you, everyone.